Here's an animation of a quarter-mile pivot with traditional drops moving at average speed. We're applying 1.25 inches of water. Presumably you have done the irrigation scheduling calculations, and this is the required amount of water your crop needs. It took 48 minutes to apply 1.25 inches of water. If everything works and you have no runoff, you have successfully matched your application rate to the infiltration rate of your soil. But what if you have runoff? What if the water being applied is not absorbed into the root zone? Then the crop is distressed. You're not getting the root penetration required for maximum yields. You are also putting fertilizer and other chemicals into the surrounding soil and streams while eroding your own fertile soil. What needs to be done? Typically, the first thing irrigators do when they see runoff is to speed up the pivot. What happens when you speed up the pivot? You reduce the depth of water applied across the entire field. In this case, we went from 1.25 inches in 48 minutes down to 1 inch in 36 minutes. The speed of a center pivot does not control the average application rate. The average application rate for a given sprinkler is a constant determined by contributing factors such as gallons per minute per acre and wetted diameter other than the speed of the pivot. The average application rate is the same if the pivot is sitting still or moving at maximum speed. The only thing you control with the speed of the pivot is the depth of water being applied. As you can see by the animation, all we did is put down less water over a shorter period of time. Although you may have eliminated any runoff, you are not getting the deep root penetration or the appropriate amount of water necessary to maximize yields. If you have tight soils such as clay or hilly ground or any other land that experiences runoff, you need a solution other than speeding up your pivot. Let's look at a drop to Boombacks comparison. Here's a cutaway of a pivot with a traditional drop spray pattern. Now let's take a look at that same cutaway and add 15-foot Boombacks. When using a sprinkler with a 45-foot throw diameter, changing from drops to Boombacks gains a 66% increase in the wetted footprint. You do not change the amount of water you are putting on, but you do change the amount of time it takes to put that water on a particular spot in the field. This animation of the two cutaways moving at the same speed demonstrates how Boombacks increase the amount of time it takes to put on the same amount of water. You can see how it takes longer for the Boomback spray pattern to move past the same point as the traditional drop spray pattern. By using Boombacks to create a larger wetted footprint, we have increased the soak time. Here's an animation of that same pivot moving at an average speed, but we have added Boombacks. We are still applying the same amount of water, 1.25 inches, but over a longer period of time, 72 minutes. We have increased the wetted diameter, lowered the average application rate, and more closely matched the soil's infiltration rate. We increased root zone penetration, eliminated runoff, and are poised for maximum yields. We also lowered the instantaneous application rate, greatly reducing the chances for soil sealing. We are now using water more effectively.